This is what my week has been like. You get like sort of something on WhatsApp. On your office hour session, are you doing 21C features? Are you doing 21C features? They come in via Twitter. They come in via email. They come in via all sorts of things. Everyone's like, upgrade 21C, 21C. See, whenever a new release comes out, it's all about the buzz. So I felt compelled. These office hours things are meant to be driven by the demand of the community, and obviously the community has spoken, and they want to basically have talks about 21C. I want to put a caveat on all of that. Yes, as RT professionals, we love squeaky clean, new, exciting things. Be aware that it is squeaky, new, clean, exciting, and an innovation release, which means for the vast majority of us, we want to be upgrading to 19C if we're not there already. It doesn't matter that 21C has come out. This is the diagram you want to be looking at, in particular when we talk about the reality of business applications. Don't get me wrong, at home, I've got 11 running, 12 running, 19, 18, 21C running. As soon as it came out, I downloaded it and had it running on my machine. But I'm not running a business. The reality is in your commercial enterprises, things like upgrades take time, they take money, they take budget, they take planning, and therefore they are a cost to your business. They're essential because we get things like security patches, etc. But take a look at the graph. 21C is about letting customers get early access to brand new functionality. But the release that's going to have the longest issue of support, the longest support, therefore not forcing you to upgrade again, is 19C. The vast majority of customers should be moving to 19C. It's the same reason why some 21C features have snuck back into 19. I know I sound like a broken record because I've covered this in previous office hours, but please, now that 21C on premises is out, don't get sort of sucked into that thing of, hey, let's get 21C running everywhere, because in 2 years' time, you're going to be having to upgrade again. Of course, if there are particular features in 21C that are business critical to you, going to give you a competitive advantage, then yeah, by all means, explore it, use it, even put it in production because it is robust. It's just the fact that you are now committing to the fact that you're probably going to be upgrading again soon. The next big long-term support release will be 23. So 19 to 23 is the logical step for most people. The other platforms, it's just out for Linux, which is obviously our most dominant customer platform. The other platforms are coming soon. Don't quote me, but I think we're looking in the sort of the 4 to 8 week kind of time frame. That's the typical thing we see. So you get Windows, etc. As I said, because 21C is an innovation release, a release we expect a small subset of customers to adopt, you won't see 21C for more of the niche platforms, things like Solaris and AIX, because the vast majority of our customers on those platforms are going to 19C and they're going to stay there for a long time and then go to 23C, for which those platforms will be out. You may have seen some panic on Twitter, people saying, oh, yes, you've ditched AIX, you've ditched Solaris. That's not true. They will be supported in these long-term releases, big long-term support releases, because they're the releases that those customers on those platforms almost exclusively adopt. One thing I am super excited about is it's not out yet, but I have seen it. I have a pre-release version. 21C will have an Express Edition release, a 100% free version of the Oracle database, obviously with some limits, but Express Edition does some amazing things, and it'll have all the 21C functionality in there. It won't be shoehorned or limited. It's a fully blown version of the 21C database, Express Edition. We expect that to come out similar time frame as to other platforms coming out in the 4 to 8 week kind of time frame, Safe Harbor, etc., etc. But yeah, there will be a 21C XE. When that comes out, I might dedicate an office hours to that in terms of ways you'll be able to make that work in your development environment if you're running 19C as your long-term support release. So I thought I'd do just a really, really quick sampler. We're going to go through this very, very quickly. A quick sampler of some of the things that I think are pretty cool in 21C that aren't the mega feature. So I'm calling it a degustation, like a little sampling of eats that we'd normally have at a restaurant. And these are some of the little things rather than the big things. Because what's the big thing in 21C? My goodness, blockchain, 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 crypto, Bitcoin, etc., etc. There's huge amounts of information out there about that. And of course, that feature being in such demand has now been backported to 19 anyway. So I'm not going to talk about that. One close related thing to blockchain that comes in 21C and also has now been backported to the latest RUs of 19 is an immutable table. I think this actually would be more popular or more readily embraced than blockchain tables because of this. Heaps of customers in security conscious environments are struggling with this. The concept of we can have all the security controls we have in place that control access to everything, except for the DBAs. Ultimately, there is some super user who has carte blanche access to the entire database. That's a problem if you're promising to things like auditors and the like that you have incredibly stringent controls. The way we generally solved that in the past is with a thing called Data Vault, which is, don't get me wrong, an absolutely robust, enormous product. It has very, very stringent, very, very precise, very flexible rules for controlling the access, auditing the access, etc. It's a complete solution. That for some customers is seen as overkill. All they wanted to do was have their existing database functionality, but stop DBAs. That's all they wanted to do. Can we stop the DBA, or can we give a guarantee to auditors that DBAs don't get the ability to silently modify data? Database Vault can do that, but it can do a whole lot of other things as well. And this is where I think immutable tables might become popular. The syntax is very similar to a blockchain table. You create an immutable table and you specify when you're allowed to delete from it, when you're allowed to drop it, etc. By the way, if you're playing with immutable or blockchain tables, just be aware. Don't set that no drop until 25 days or 100 days just for giggles, as I tweeted out recently, because the only way of circumventing that, if you've created a table that has a retention of say 6 years, is to drop the entire pluggable database. When we say tamper-proof, when we say immutable, we mean it. You will not be able to drop it even if you're sys. Assuming you've set some reasonable timeframes there, here's my table called no messing. I simply populated it with the scott.emp data. And as you can see, I can't update it. The only thing I can do with an immutable table is insert into it. The rows that go in there are locked and locked forever. And I ran that as the sys user. Doesn't matter. There is no DBA privilege or above sysdba, etc., that will let you touch the data in an immutable table with the exception of simply inserting into it. Obviously, you need to have some careful thought before you do that. What if I do need to make some changes? This is a tamper-proof table. It's not like tamper-proof, but here's the secret backdoor. This is literally a table that you can't mess with. Other cool things coming in 21C. Some plan tools. One of the things that we often do as developers is we run the explain plan command. We know it's not a guarantee, it's going to be the real execution command, but often it's a good sort of first step in terms of checking whether we're going to have some useful stuff. So I can do a couple of different explain plans here. I've explicitly put some hints in to get different plans, but typically we would look at, for example, 2 statements that might give a similar plan or slightly different plan. But now in 21C, I have a nice facility called compare explains. If I've set the statement ID, or flick back, if I've set the statement ID, I can literally set them, what have I got, P1 and P2. I can now pass them into the compare explain facility, which is new in 21C, and you get a nice report. We've had this before for comparing plans that are sitting there in Fetal or SQL plan. Now you can do it for stuff that's in your plan table as well. Similarly, we've got compare cursor. So rather than having to find the plan ID, you can just type in the SQL ID and also the compare explain you just saw there. Friendlier analytic views. Analytic views are super cool, and I'm not going to spend time on this. There's some good examples on Live SQL. Analytic views are really cool in the sense that you sort of define how your data is hierarchically stored in your warehouse, which dimensions relate to other dimensions, which relate to the fact tables, etc. You're sort of mapping all the various joins that would be done in order that people don't have to write those joins themselves. So in this query, I'm simply selecting from the sales analytic view and nominating some hierarchies. I want to get the hierarchy for time dimensions for a particular year and department dimensions. I can get year, month, quarter, etc. I just wrote a single query against what looks like a single view, sales analytic view. Under the covers, we morph that into all the queries you need, joining to the dimension tables, the hierarchy tables, and the fact tables to come up with the solution that you see there, just that nice little summary. Notice there's no aggregation there. I didn't have to do sum or max or min. It just does it all for you. Under the covers, obviously, a whole lot of stuff is going on with analytic views. And so, for example, that particular query, if I plug that into DBMS utility expand SQL text to see what the real query was when I threw that across the line to the database, it looks like this. In fact, it doesn't look like this. It looks like this. Enormous amounts of complexity. Now, there's a lot of long aliases there, but the reality is that's the kind of queries that we used to ask our business intelligence people to write, or the BI tools to write, that the database can now do for you. I find our BI people would much rather run a query like that. It's much more analogous to the actual requirement they have. I want to get department totals by year against my sales analytic view. The problem is massive queries like that can obviously sometimes have performance issues. And that's one of the dangers of hiding complexity from people, is what looks like a trivial query to them is actually an enormously complicated piece of computation going on. And therefore, they can get upset when these things don't run as fast as they would like them to. A new facility in 21C is this thing called AV Tune, which will look at usage, it'll look at the structure of things and come up with recommendations in terms of caching the results like a materialized view, etc., or automatically refreshing them. There's various facilities in AV Tune to make sure that when they run these what look like simple queries, they get the kind of response times that look like you would expect from a simple query. Gradual password rollover is a nice one as well. Here's an example of how we would do it. We create a profile called Let's Be Gentle. We're going to be gentle to our users. Create a user with a password called My Current Password. And he's got the profile, or she's got the profile of Let's Be Gentle. Therefore, I can connect with my current password. That's just stock standard Oracle, nothing there. However, I can log on as a SysDBA or any kind of privileged user and change their password to the pesky auditor's new password. Because the auditors are the kind of people that come and say, yes, you must rotate every single password every month, every 6 months, etc. With the rollover, I can now connect as the new password, as you'd expect, but I can also connect as the old password for the nominated period. I did a rollover period of 4 days, so I can have 4 days in which I can actually use both those passwords. You might be thinking, well, big deal. Like, what's the benefit of that? Why would I bother, with a rollover password? Surely I just tell the user, yep, I've reset your password, off you go. The real benefit I see is in the arena of application servers. Because what we generally do with application servers is we'll have credential style wallets stored for each application server, and we could have hundreds of these. And in that wallet, we have the username, password, and the TNS name that we'll be hooking into to connect to the right service. Therefore, in the configuration of all our app servers, we never have usernames and passwords. We just have connect/at service name. That's good because there's no passwords stored in configuration files. Obviously, though, when I change that password, well, if I change the password, that means every single wallet needs to be changed at the same time. Otherwise, I'm going to break my application service. I can't do a nice rolling change. And I've had this at customers in the past where, because auditors have said, even for things like app schema passwords or application user passwords like this, they're not allowed to be kept in place forever. They must be rotated. We literally had to do it as part of an outage because you're sort of stuck in that risk model of, if I go change the wallet while the application is still running, well, that means if the application crashes, it won't be able to reconnect. If I leave it till the application is down, then of course I can't do a roll through because half those application servers are using the old password, half are using the new password. You have problems. So you have to take a complete outage, which obviously sucks. So yeah, gradual password rollover I think is going to be really useful for those people that actually have application server passwords stored in wallets. We have a nice safer version of Data Pump now. One of the cool things with Data Pump is you can unload data and in it goes to a flat file. But what's in that flat file? Well, it's just data, hence the term Data Pump. So you can see here, if I do an export of the Scott schema and it dumps out, department, etc. Well, there's nothing to stop me bringing up a hex editor and going and hunting around in the code. Now, changing strings is trivial. I've changed Martin here to Connor. I've become an employee in this table. With a little bit more care and patience, I could actually do things like change people's salaries and stuff. The moment data goes outside your database, it is obviously less secure than being inside your database. And the problem there is you just import your data back in and voila, employee Connor has now magically appeared from that hacked data pump file, even though it used to be Martin. And you'll never know. There's no warnings. There's no nothing. One of the nice things we've done in Data Pump now is this new thing called checksum equals yes. It will make your data pump a touch slower because at the end, we run a typical sort of checksum command on the data pump file. You could obviously do this manually with MD5 and stuff like that, but it's just nice to have it integrated with inside the product. When it comes to importing, I do verify checksum equals yes. And you can see now that I've hacked the file, it said, no, you've done something dodgy. Someone's messed with your data pump file, and therefore you can't import it anymore. You might be thinking, well, hold on a second. Yes, I know someone's hacked it, but I still want to see what the contents are. That is an optional parameter. If you don't put it, you will be happily allowed to import that data pump file still. I would sort of have a standard operating process of you always specify this, and then if you get a failure, then you might choose to import it into a different database, different schema, etc., just to do a validation check on what's going on. But be aware that just because you put checksum yes on the export doesn't mean you will not be able to import it just because it fails the checksum. You get to choose. There's some really cool stuff coming out. This is a bit of a banner headline feature, so I'll fly through this very, very quickly. In terms of database resident logic, i.e. MLE, the multilingual engine or part of the Graal VM. One of the cool things you'll be able to do is put non-PL/SQL code into the database like we do with PL/SQL code, things like JavaScript, Python, etc. Code that is close to the data is generally going to work better with data. So for example here, I can literally, there's a little bit of wrapper around it, but what I've done is I've got a piece of JavaScript here, which is hello world, and there we go. It actually ran a piece of JavaScript code in the database and spat it out. Spitting out hello world is not the most profound thing, but it also lets you talk to the database. We put in some various extra bits of the code there. Oracle, MLE.js, Oracle DB required, so a JavaScript package, some SQL, and you can actually interact with the database as well, in this time from JavaScript, and print out the results of select star from the employee table. Even that, you're going, well, big deal. Like, why would I want to throw away 30 years of maturity in PL/SQL? And PL/SQL still, is the best language to interact with the database. It's so seamless. You just code the SQL straight in there. Why would you do this? Well, think about all the things that have happened in the world regarding JavaScript. There's a sort of a common phrase where you say, you never need to write anything in JavaScript nowadays because a library exists for it. Every possible function has been written. Here's an example. In JavaScript, there's a library out there called Validator, which lets you validate things like valid email addresses, valid URL syntax, etc. You could write that yourself in PL/SQL, but then you've got to make sure it's correct, you've got to test it, etc. Why not grab a library that's been used by a bazillion JavaScript programs already? Load that into your database, and there you go. You can now do select star from the emails table with your new function, is email valid, and that's actually running a JavaScript implementation. So you'll be able to have a much more extensible SQL language and PL/SQL language by taking advantage of JavaScript libraries that have been written and tested ad infinitum. One of the things I think probably is going to be the biggest, most popular thing in 21C, and therefore will certainly be huge maybe in 23C when it becomes long-term support, is JSON is just across the board easier in 21C. It's just much more seamlessly part of the SQL engine. So I can create a table. We got a new data type called JSON, but you can just stick strings in there. It'll just automatically do the mapping for you. So there's a name of Connor. I spelt my name wrong deliberately. I live in Perth. Funnily enough, if you're in SQL plus 19 like I was, you'll get undefined for the JSON data type. SQL plus 21 obviously understands what this data type is, but in SQL plus 19 it goes, you have this new data type called JSON. Don't know what that is. All the normal JSON value stuff works, but also straight out of the box you can use the dot notation. Don't have to have the check constraints of is JSON and stuff like that. I can do serialize to get nice pretty printing. So that it came out in a nice sort of JSON hierarchical structure for me. All that stuff is integrated with PL/SQL as well. So those existing JSON data types in PL/SQL now accommodate the JSON data type in 21C just seamlessly. So I can, for example, I can use object has and object put to check elements inside the JSON structure. So in this case, I've put in an extra element of status added to this JSON on the fly coming out of PL/SQL. And you get this lovely syntax now for amending your JSON. So for example, here I'm doing a couple of sets which change the values. I've got things like rename, so I can actually rename the key element. So I've changed the element name to first name. I've fixed my typo in my name, that's CONNOR. Append, I can add new elements to the JSON, just all natively within SQL. Lots of really super cool stuff. Even if I got JSON arrays, which has always been a little bit of a bone of contention in the database, because what if I have an array of 1,000 elements? That's still just one row in a database. How do I index that effectively? We used to do full text search. Now we have a thing called a multi-value index in 21C. It's actually designed for JSON elements where you have multiple values inside one row, one JSON fragment. And I can do where JSON exists, looking for the zip code of 1234, and you can see it actually use that multi-value index now. So it's a new index structure explicitly designed for getting really fast performance in terms of JSON extraction, etc. The attention log. This is my Oracle 21C instance I installed the other day. Literally, I've started it and run a few demos, and already my alert log is 300 kilobytes long, and that's generally a pain, because when you look at the alert log, it used to be, if you're a dinosaur like me back in Oracle 7, the only thing that went in the alert log was when you started the database and when things went wrong. Couldn't extend a data file, you're out of space, got a data corruption. That was it. The reality is the alert log has morphed over the years into being any kind of diagnostic information that's going to be useful for DBAs or for support. And I'm a fan of that. I'm a huge fan of capturing more and more logging information, because when things go wrong, the more information, the better. The problem is digging around through here to find out when things are bad is hard. That's why we have this new thing called the attention log now. You can see it's much, much smaller on this database, which has only been up for a couple of days. The attention log is a JSON format, which is really our attempt to digest all that data in the alert log and come up with things that are much more critical for you to look at. Now, when I say critical, it's not just bad stuff, but we're trying to classify the information for you. You can see the first one there, it says, we've got some information here. It's an info. The urgency is info only. We're starting the database. It's an important milestone. The database is started. You want to know about that, especially if it's resulted from a crash, but it's just information. However, urgency of soon is, hey, you shouldn't be running 21C with 25 other databases on your laptop. That's a fair point. And that's why it's swapping heavily. I've got my little VMs very, very small on memory. But you can see it's a much more structured format, and we're trying to classify the information. That's going to be great for official and your homegrown tools. But in particular, it just helps sort out all that data in the alert log into something which is going to be much more digestible to you as a DBA if you need to take action in terms of a critical basis on your database. There's a lot more. The full implementation of SQL macros comes in 21C. We got table level in 19C, but we got scalars as well in 21C. Some new threading facilities in JDBC to make it faster. We've got zero time zone upgrade. I used to hate having to bounce my database just because Djibouti has a new time zone, or they've adopted daylight saving, etc. Now you can do it without taking the database down. JVM patches, no longer having to stop the database to apply a JVM gem patch if you got rack. Unified auditing becomes the default in 21C, and now when you apply unified auditing policies, they immediately take effect, even for existing sessions. So it's not like you have to wait for people to reconnect to pick up those new policies. You may have seen, if you've tried to install Oracle 21C already, it's a read-only Oracle home. So that's nice. We've separated We've broken the microphone. We've separated configuration files, SP file, TNS names, ORA, etc., from the software itself. That's always been a sensible thing to do. People used to do it with symbolic links. Now it's part and parcel. We have this thing called a mandatory profile now. You can set a profile which is mandatory. So people can't say, oh, I don't like those minimum password requirements. I'm going to create my own profile and circumvent that. You can, at the CDB level, you can say everyone has at least this bare minimum level of profile restrictions. Pluggable data guard is here now. Data guard at a pluggable database level. Automatic in-memory. The database will make decisions as to what objects to put into the in-memory for you. Automatic partitioning. I've seen a demo of this. Some of these things are going to be engineered systems or cloud only, but auto partitioning is already available on our cloud, which is you've got a massive table, the database looks at the queries, and it'll partition it for you. That's pretty cool. Automatic materialized views, dynamic CPU scaling for pluggable databases. You can say that pluggable database gets between 3 and 5 CPUs as opposed to having to set a particular limit. PL SQL has a whole stack of new iteration facility. I did this in a previous office hours. The looping constructs are now insane. PL SQL qualified expressions. Prepare for data guard. That's super cool. It's a data guard broker facility. You say, I want to prepare that database for data guard. And it does all the preliminary steps that you would normally have to do manually, etc., 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 etc.